Good morning, Freedom High School students, or good evening. This is Miss Malatin, and today we are going to make a Bohr model of an atom with help from the periodic table. So we have the periodic table that's in the center of our chemistry reference tables, and we're going to do magnesium today, a magnesium atom. So we go over here and we find magnesium, and we set an atom. That means it's neutral. That means there are the same number of electrons as protons. So we see right here we have 12 protons, so an atom of magnesium will have 12 electrons. 12 electrons. So we're going to keep track. We're going to come right here and we're going to say 12 electrons. We're going to keep score. We are going to start by representing the magnesium atom. Nucleus, we'll call it magnesium. We know we have 12 protons. And the most abundant isotope, if we round the atomic mass to the nearest whole number, be 24. And so that would give us the mass number of the most abundant isotope. So the mass number would be 24. If we take 12 out, then we have 24 neutrons. And that's our nucleus. So around this nucleus, we have an electron cloud with electrons orbiting at certain discrete energy levels. And we'll start with the first energy level, draw a circle. That's n equals 1. And the easy way to figure out how many circles you need to draw, what the maximum number of energy levels is for an element, it's pretty convenient. If it's on the first row in the periodic table, not this row telling the title, the row with the actual elements, this row will have 1 energy level maximum, row number 2 will have 2, and row number 3 here for magnesium will have 3 energy levels. So, I will draw three energy levels. Now, when we learn from our notes that the first energy level can have a maximum of 2 electrons. And instead of just dots, I'm going to just number how many there is so I can keep track. We have 2 electrons maximum on the first energy level. And those are flying around, whizzing around in that area completely around the nucleus, not just in a planetary orbit. But we found seats for 2 electrons. It's kind of like a concert. When people go to a concert and they go in, they fill up the seats closest to the band. So the first row of seat fills up first. The first row has a maximum of 2 electrons. So we found seats for 2 electrons. So we now have 10 electrons that still need seats. Well, you know from your notes that the second energy level can hold a maximum of 8 electrons. 8 electrons. So we found seats for 8 more. We have 2 left. Now, just like a concert that doesn't sell out, this third level has 8 seats. But we only have 2 electrons. Well, that's all that's going to be there is 2 electrons. There's 2 electrons and 3 places just go unfilled. So magnesium, and you can go back and count and double check, you have 12 protons and 12 neutrons. The number of electrons should equal the number of protons. 2 plus 8 is 10 plus 2 is 12. And you do it that way for all of the atoms. When you get to energy level 4, it gets a little bit different, and we'll get to that later on.